Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn about the concept known as supernode. Okay, so whenever we apply nodal analysis to solve any kind of electrical circuit, at that time, whenever there is a voltage source connected in that circuit, for example, like in this case, we can see that this particular voltage source is connected in the circuit. Okay, so we apply the concept of supernode. Okay, so let's say this is the reference node. Okay, and let's say this is your node 1, this is 2, and this is 3. Okay, so according to this concept, we assume the nodes across the voltage source as a supernode. So let's say this is your supernode. Okay, so we apply KCL at node 2 and node 3 simultaneously. Okay, so after applying KCL, okay, at node 2 and 3, we can say that, so the KCL will be the sum of incoming currents is equal to the sum of outgoing currents. Okay, so it means that I1 plus I2 plus I6 is equal to I3 plus I4 plus I5. Okay, on further simplifying it, we can say that the value of I1 will be equal to, if this node is 1, then the voltage across this is, let's say, V1, V2 and V3. So on substituting the values of the currents in this equation, we can say that I1 will be equal to 3 amperes plus I2, which is equal to V1 minus V2 upon 3 plus I6, which is equal to V1, so plus V1 minus V3 upon 4 is equal to I3, which is your V2 upon 1 plus I4, which is equal to V3 upon 5 plus the value of current, which is I5, which is equal to minus 25 amperes. Okay, so this is how we apply the concept of supernode. So we apply KCL simultaneously at both the ends of a supernode, which is your, in this case, which are 2 and 3. Okay, so in this technique we apply KCL at both the nodes of a supernode simultaneously or at same time. Okay, same time. Okay, so now let's apply the concept of supernode in this problem to understand it more deeply. So let's say this is your node 1. Okay, this is your node number 2, this is 3, and this is your 4, and this is your reference node. Okay, so as you can see in this diagram, there are two voltage sources, this one and this one. So we can apply the concept of supernode in on these two voltage sources. Okay, so this will be your first supernode. Okay, and this will be your second supernode. Okay, so now let's assume the direction of currents. Let's say this is your I1. Okay, this is your current I2, this is I3, then I4 and I5. Okay, so on applying, so for supernode 1, okay, so for nodes 1 and 2, after applying KCL, we can say that, so on applying KCL, I1 plus 10 ampere current source is equal to I2 plus I3. Okay, so it means that the value of I1 will be equal to 0 minus, let's say the voltage at this node 1 is your V1, this node 2 is your V2, this node 3 is your V3, and similarly the node voltage over here is your V4. So it means that the value of I1 will be equal to 0 minus V1 upon 2 plus 10 is equal to I2, which is equal to V1 minus V4 upon 3 plus V2 minus V3 upon 6. Okay. So on simplifying it, we are getting the value to be equal to 5V1 plus V2 minus V3 minus 2V4 is equal to 60. Let's say this is your first equation. Okay. So similarly, on applying the concept of supernode for 3 and 4, so for nodes 3 and 4, we can say that, okay, so on applying KCL, so I3 is equal to, so I3 is equal to I2 plus I4 plus I5, okay. So on substituting the values, we can say that V2 minus V3 upon 6 is equal to I2, which is equal to V1 minus V4 upon 3 plus I4, which is equal to V3 upon 4 plus V4 upon 1. Okay. So on simplifying it, we are getting the values to be equal to 4V1 plus 2V2 minus 5V3 minus 16V4 is equal to 0. Let's say this is your third equation. Okay. Also, from this diagram, we can say that V1 minus V2 will also be equal to 20 volt. Okay. Let's say this is your fourth equation. From this diagram, we can say that V3 minus V4 is equal to 3 times of Vx. Okay. So using the second equation, we can say that Vx will be equal to, so Vx is equal to V1 minus V4. It is already, okay, so we can already see that. So it means that on substituting the value of Vx, we can get, so V3 minus V4 is equal to 3 times of V1 minus V4. So this implies, so it means that this implies 3V1 minus V3 minus 2V4 is equal to 0. Let's say this is your fifth equation. Okay. So using the equations 1 to 5, okay, we can say that the value of V1 will be equal to 26.67 volts. Okay. V2 will be equal to 6.67 volts. V3 will be equal to 173.33 volts and V4 will be equal to minus 46.67 volts. Okay. So I hope it is clear how we are solving this problem. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel.